So good morning, welcome to Ljubljana. Welcome to our team. I work with Tanya for years now, and so what I wanted to talk today is a little bit about what is the follow-up, or what are the next steps for what you've seen in the Tanya's presentation about how we are actually using and able to implement various methods from the, let's say, very sexy domain now about artificial intelligence for various purposes. So I am not an expert in the medical domain, although I've seen quite a lot of projects, but I'm the expert, and what we do is usually we try to implement those methods to understand complex systems. And complex system could be anything. So from this media space to, let's say, media space with fake news and all the other stuff, to smart cities, to global warming, but also to diseases. So what we usually do, and what I wanted to show you today, are how we actually implement these methodologies to something that is the case that you are working with, and where we think that this might certainly help. And so the observatory that Tanya was showing you is just a first step. There are two others, and I will explain a bit about these two others. And in particular, I want to show you different views through a concrete examples that we do, different views and different capabilities of that kind of approach to actually help the understanding the environment that you are dealing with. So what I'm presenting here is actually one of the entities that we are running. So it is the International Research Center on AI under auspices of the UNESCO. And now, since I'm involved with this UNESCO things with several hats, this is certainly a very, very good and interesting mechanism. So the other part of the talk would be about how actually can we together use these mechanisms to make these things a little bit more streamlined as it is today. But this is, as I said, so everything you will see, in particularly for the rare diseases, is my personal view on the domain. And let me start with those 5 key points, which are now from the AI researcher view into the domain. So first, when we talk about and when we see what you're dealing with, certainly there is a domain that you have many unknown unknowns, which in some essence means that you get across too many black swans. This is one side, and the other side is that in all these cases, in much of these cases that we've seen, there is usually a case that you don't even know, or we don't even know what to ask for. And those are the things that certainly that kind of technologies can bring a value into it. So showing you things that might be completely out of the mind, out of scope, but certainly very important. And so what we see, what you're looking for is actually a kind of a mechanics, understanding how these rare diseases are working. And mechanics, it's about understanding causalities. It's about understanding what are correlations between different types of impacts to this rare disease, which would be, everything from what you do as a clinical analytics, what you do as when you are doing the genome sequencing, up to something which would be reports from the parents, and then maybe things that are actually influencing those things, which might be global aspects. So certainly this is first thing. The second thing that you have, and I mean, rare diseases is in fact essentially a lot of small communities, and because there are rare diseases, they're not very popular. So the question would be why those things could not be put together into something which might be then becoming a relevant and a very interesting entry point, as Tanya was showing you before. And then this is a global challenge. So global challenges mean that, from our point of view, that would be different sorts of data, different sorts of content, different sorts of modalities, things that are in structured databases, things that are in the text like news, things that are in the published articles and so on. So it's not just about counting those things, it's about really understanding what's written in those things. So really getting the essence out of all this information media, which might be in different forms, as I said, in different languages as well. And those are all methodologies that we actually master. So we are able to collect all this information and then try to make something out of this. And then you have a wide range of stakeholders. So it's everything from doctors, researchers, parents, policymakers probably. And in most cases, what I've seen, they are very devoted. It's not the case that that would be in the other places. I've seen that kind of a environment as well in these open source communities. Open. So I'm the UNESCO chair for open learning. And it's really about this devotion, understanding that this is something that helps someone. That the work that you are doing, the work we are doing, is actually have a sense, have a meaning, and has a value. So this is something which is, certainly a positive point. And then, of course, is the latency. In particular, in particular, in medical space, this latency is quite important. You know better than me how much time it needs that you come from something which is a prototype to a procedure or to a medicine. And so those things could be speed up, at least in a way that you would see all this, as I said, mechanisms and causalities between different sorts of influences to, let's say, a particular subject which has this disease. So those are, let's say, 5 key points that I took out from this discussion that we have in recent years, and in particular from the stuff that we've seen. Now, the question, of course, that I said is, why can we put all these things which are now dispersed and diverse and small and islands here and there together in something which would be let's say, a unique entry point, which is not just about showing and counting things, but also doing a little bit more deep analytics, and of course, then also the prediction and planning, which might be then put as a service, as a personalized support for every individual in the stakeholder, not just the kids that are having the disease, but also all the other stakeholders that are dealing with this. And for that, there are several options, but certainly what we do is actually creating this kind of we called it digital twins, and this is understanding or collecting all this information, all this data about the complex system, and out of this complex system create a model that we can then use for all these things. So first, what Tanya was showing you is this middle point, so understanding the present, so what is going on right now. But if we have a history, historical information, and you are collecting historical information as well, then of course what we can do is do a little bit different things. And that would certainly mean going deep into the analytics. And now analytics doesn't really mean just, as I said, counting things, but really go down to the essence and find out the things and ask questions which might be very, very relevant for these stakeholders. And if you have a history and if you have the present, then of course, these mechanisms are allowing you to do predictive analytics. And predictive analytics is very, very important when you are trying to do something which is a plan, which might be, in this case, how would you deal with a particular disease for a particular individual? And those are the things that we develop. Those are the things that are not actually anymore a research part. Those are the commodity facility, and we use that in different places. So the common idea behind it is that you create something which is it's kind of automated situational awareness, which actually mimics. This is a kind of a mimicking the human cognition. So from the perception to comprehension to projection, and then you do planning and action back to the environment. But this is just to show you that this has something which actually then provides you this thing. So essentially, that kind of models can answer those type of questions. So what is happening, when is happening, where is happening, who is involved, or what entities are involved, or what viruses are involved, or what genes are involved. Who is where is the origin? What is where it actually things started to evolve? And then, of course, why, when you go a little bit more in detail into this deep analytics and ask questions which are hidden in the model and you want to know and you want to understand. Because if system will only tell you, you should follow this route, and if you are the decision maker, in particular the doctor, then you have to know why the system proposed you to follow this route. And then the next thing is what if? So what if we can have this kind of a model and then do experiments on the model? You know, experiments in the model could be actually experimenting in the virtual space the things that you are trying to experiment now in vivo, which is a completely different thing. Now, those are step-by-step approaches. It's not that everything is there already. It's just that I'm saying that we have technology and methods that can allow this if the data is there on the other side. Now, let me show you several examples. So why I'm showing this is because this is the latency, as I said. So this methods allows you to do things in real time, in close to real time. So one of the surveys that we are running, and Tanya was showing you, is actually understanding the media space, which is, again, a complex space. It's a global, it's multimodal, different languages, different people, everything inside, millions. So we are actually reading million+ articles every day. And the analytics that we do on these articles is roughly around 2.4 billion articles. So when you do analytics on top of this database, that would mean that you go in this huge, deep space of information and try to understand what's going on and what are the predictions of potential consequences of an event, because we have now the history. So real-timeness, this is point number 2. Point number 2 is predictiveness. So here is one of the projects that is live, so you can go into this website. This is the global digital twin of AI, because we do AI, and we are, of course, interested in what is happening in AI. But what I wanted to show you here is that actually we have various different data sources. You have various different data sources. We can connect all these various different data sources to create a model. So it's just about, and Tanya was actually telling you, so just start collecting all these data sources which are available, might be relevant, or we don't think that are relevant yet, but we can test whether they have some influence on the model that we are creating. So what actually I'm showing you here is that we are now able to create a model that were early in the beginning when the idea, for example, in the area of artificial intelligence, which would be a scientific paper coming out, whether this idea would have possibilities to come at the end as a game changer in the area of artificial intelligence in the next 5 years. So predicting things very early at the beginning that might have a significant consequences globally in this space. Now, those are all global databases, and Tanya is already using some of those global databases, which means that we have access not just to the database about AI, which is the case for the OECD, but also for medicine. It's just that we are not using that yet. But those are global databases that we think might be relevant. But if we connect those global databases with your internal database, research databases, your reports of parents, all the other stuff which goes around rare diseases, then this becomes a little bit more powerful view on it. So predictiveness. And then the next thing, so situational awareness. So I said, so we are now, Anya was showing you the observatory, the first part. We are getting into the next part, which is simulator, asking what if questions. So which is the predictive element already. And then when you have model developed, then you can do the third thing, which is personalization. So you create this system, which is for the first and the second part mostly observing. So it's actively observing and predicting, to something which is a proactive system. So a system that can actually proactively show and advise you what to do. And here is just a case that we are developing right now, which is understanding a complete country. And you see again different sorts of different types of information, and then different types of outcomes that are relevant for various stakeholders. So it's kind of the same thing. It's just about trying to understand all these scenarios in between. And then experts in the loop. So all these things I showed you before, it's about accessing the data, collecting the data, doing analytics, doing prediction, what if analysis, simulations, whatever. Now, what we are also capable of doing is actually to involve stakeholders directly in the loop, which would mean that the system will learn from the actions of the experts. Or the system might ask questions, might look for information from the experts, which it cannot find in the environment, in the model. So it's not just about having a machine, it's about having a complete ecosystem of machine and humans empowering each other. This is what we are talking about. Now what we do in IRCAI, we are developing that kind of observatories. So for all these SDGs, so you've seen part one of the Tanya's SDG, but there are others as well. And we go gradually, step by step, because otherwise it would be just too much. But certainly those are the things that what we want to do as a openly accessible views on things that are certainly challenging in the globe, global challenges. When ChatGPT came across, it just half a year ago, the good thing with ChatGPT was that was open AI. If this thing, the ChatGPT, would be somewhere there hidden in whatever Google or whatever large thing, providing you all this information without us being aware that this has these powerful things behind, then this is a completely different thing that now when we are aware of the possibilities. And this is why all these things has to be openly transparent. So not just showing you results, but also showing you how it works, where the data comes from, how the data is being handled, and all the stuff which is necessary for people looking at those things, as I said, various stakeholders, being certain and confident with the results that the model is giving. Now, there is no particular issue. So this is what we do in IRCAI. So a lot of things you see from the infrastructure out to policies, because we are the international part of the international organization. We need to do policies as well. But there is no particular issue why in the scientific program committees that we have right now, and we are again building this gradually, there will be no number 7, which will be rare diseases. So I was talking to Tanya already. So this is easy. So you being part, you create your own committee, your own program, but then you have UNESCO label. Now, what can you do with UNESCO label? Certainly, whatever we do in IRCAI goes in 193 ministries of science and education across the globe. So it's a powerful mechanism. We just need to use it properly. So it's a powerful mechanism. This is number 1. Number 2 is since we're involved in the international organization, and WHO is a sister organization of UNESCO, the doors are getting openly differently than if we're just coming there as a JSI or roundabout university. So this is number 2. And number 3 is that UNESCO is about science and research and education and global science. It's not culture. Culture is the third part of it. And these mechanisms are also opening doors to policies on one side, which would be a mechanism to create, if it is needed, a global policy on rare diseases, or opening the doors to somebody who is actually a global investor. So, but for that, of course, you need to have manpower. You need to have something which was the number 7. You have to have experts that can answer questions. I cannot, right? And then you have to have something which is a kind of reliability of the system, so that, you know, there will be not 2 persons sitting in committee, but, you know, a wide spread of experts across the globe. So, 2 things. There is no particular issue why this kind of observatory will not become something which is a global digital twin that can also help you do research and simulations and all this stuff. And number 2, there's no particular issue why you should not be involved and use the mechanisms of the UNESCO. And this is actually what I wanted to conclude with. Thank you. So if you have any question, any debates, just don't mention ChatGPT. Everything else is okay. So
I was wondering about the healthcare and what is the experience so far with connecting to all kind of healthcare initiatives?
So this one is more like a traditional medicine. So a kind of a traditional view on medicine. It's not rare diseases per se, okay? But all these committees are working to each other.
Are there partners from hospitals and thinking about how to...
Mostly researchers, okay. Mostly scientists, So here in most cases you have researchers from the domain plus AI. There are a few cases that you would have somebody, for example, from the industries or hospitals into involved it. But you know, this is completely open. And it's up to you to divide the group. Program, group, goals, and then it's number 7, and then you know, you use all the mechanisms, and she would be responsible for that. So
Thank you very much for an interesting lecture. It's the implications are incredible. I was just wondering, you feed these probably large language models with all loads of data. What about copyright? How do you make sure that you're not violating copyright and you know what kind of open issues you're tackling?
So large language models, this is one of the method. So large language models are using more or less neural networks, which is one of the methods of the complete space of AI. So here what you've seen is actually something that is not large language model. What we're building here is the same kind of a model, but in the descriptive way. We try to understand how the model actually works. So that's the difference between neural networks and the other models. And this is not a large language model. So large language model for us is one of the components that we can integrate when necessary. So copyrights, now it's a different discussion, right? So there are several, right now you have several legal frameworks. For example, legal framework in US says that everything that is being produced by the machine should be accessible and open. So there is no, so if you actually would be now creating something through the large language model, which would be a textbook, then this should be in the public domain, according to EU legislation. So European legislation is a little bit lagging behind, but this is mostly because the publishers are so strong in Europe.
My question was regarding the input data. So taking in scientific findings from journals, from textbooks and so forth. How are the authors compensated, or how the...
So most of the databases that you've seen are open publicly open. And what we don't do, we actually then, so we create a model and we show the results with links. If this would be, for example, the case for the media space. You use the data, you create the model, and then you forget about the data and then you show the links. Yeah, we have these questions all the time, so issues about the copyrights. And since I'm the UNESCO chair of Open Educational Resources, I'm fighting against the copyrights. Yeah.
Do we have any other questions? Okay.